As I mentioned, nuclear reactions normally produce a lot of energy. Let's take a look at this reaction of the fission of uranium becoming the nuclei of barium, Ba, and kryptonite, or Kr, while also releasing neutron particles. First, always check whether this is already a balanced reaction, and you can do it by making sure that both the mass numbers and the atomic numbers have been the same for both sides. Now in this case, we can calculate the energy based on the Einstein equation, which is E equal to mc squared. And the m we will obtain actually from the mass defect. So the mass defect is the mass of the products minus the mass of the reactant. So in this case, we can calculate the mass defect from the sum of the mass of barium plus mass of kryptonite plus 3, don't forget the coefficient, mass of neutron minus mass of reactant, so mass of uranium plus only one of the neutron particle. And normally the unit will be in AMU, or atomic mass unit. And in this case, you will have the delta M in a certain value and in the unit of AMU. To be able to use the Einstein calculations, we have to convert the AMU to kilogram first. And to do this, we have to multiply the value in AMU with 1.6605 multiplied by 10 minus 27th kilogram over AMU. So we can cancel out the AMU. And after this, after we got the kilogram, then we can further multiply with the c squared, or the speed of light squared. So 3 times 10 power to the 8 squared, or meter squared over second squared. Now in this case, we will get the energy in the unit of joule as we want it. And normally the value will be negative because this process would releases a lot of energy. In some cases, they ask you the energy per mole of the uranium. Now, note that the energy that you calculate here is actually the energy per uranium particle. So for each uranium particle that undergoes fission reaction, this is the energy that it would release. Therefore, if we would like to find the energy over mole, of course, we have to take the energy per particle, or the one that we write in yellow. We multiply this with the Avogadro's number, which is 602 10 power 23rd particle over mole. So you can calculate the energy per particle, which is only in joule. But we can also calculate energy per mole. So the unit later will be joule over mole. Joule over mole. And this we do by taking the energy that we have calculated for joule, or for per particle. And then we multiply this value with the Avogadro's number. So as you can see here, we use the Avogadro's number to be able to get the value of energy for joule per mole of uranium particle.